All right, in this polynomial long division deep dive, I'm going to walk you through 4 examples, each getting more difficult than the last, so that you can master this strategy that isn't really that difficult with practice, but it is long. Before we get started, be sure to polynomial long divide that like button so that other people can see all these tips and tricks as well. All right, so in this problem, we're dividing x squared plus 5x plus 6 by x plus 2. Now, polynomial long division is really the exact same thing as the long division that you learned, way back in like grade 5, but we're working with polynomials. We've got variables and we've got numerical terms. So it's going to be a little bit more complicated, but the process is going to be the same. All right, so the first step is we're going to look at the first term in our dividend, which in this case is going to be our x squared. And we're going to ask ourselves, how many times does the first term in our divisor go into the first term in that dividend? Now, this is where a lot of people right away get confused. And I'm going to show you a little trick that I use to make this a little bit simpler. Instead of just, looking at this problem as a whole, I like to kind of go off to the side and I actually write this out. I say, well, if I take that x squared and I divide it by x, what do I get? Okay, now what do I get if I divide x squared by x? This is kind of like an exponent laws type problem. If you think back to your earlier studies of exponent laws, I have x squared divided by x. There's a little 1 there in the power. And because I'm dividing two powers with the same base, I can subtract the exponents, okay? So I can subtract 2 minus 1, and I'm going to end up with x to the power of 1. I'm not going to write the 1 here, I'm just going to write the x. So I like to write that whole process out off to the side so I can make this whole process a lot more visual. Now, what am I going to do with that result? I took my first term of my dividend, and I divided it by the first term of my divisor, and I got x. Okay, well, I'm going to put that x right up top here, above the x term in my dividend. Okay, so above this 5x, I'm going to write that x. Okay, that's your first step in your polynomial long division process. The next step is we're going to take that result, that x, and we're going to multiply it by each term in our divisor. Okay, so I'm going to take x, I'm going to multiply by x, and whatever I get, I'm going to write down here. And you can write this out off to the side as well. I have x times x. Again, this is just like an exponent laws problem. If I'm multiplying two powers with the same base, I can add the exponents, right? I have x times x, that's just the same as x to the power of 1 plus 1, also known as x squared, okay? So that's going to be the result here when I multiply x times x. And I'm going to put that directly underneath the x squared. Okay, so keep your exponents lined up with one another as you go. Now I'm going to repeat that process by taking x and multiplying by the second component of my divisor, which in this case is 2. If I take x and I multiply by 2, I know that that's going to be 2x. So I'm going to write my 2x below my 5x term. And at this point, I've multiplied that x by everything in my divisor, so I'm going to stop here. Okay, so that's the entire second step. All right, so the next step here is I'm going to draw a line across here, and I'm going to do some subtraction. And since I'm subtracting, I'm going to put this entire expression in brackets, okay? I want to keep all my signs straight here. And I'm going to subtract straight down. So I've got x squared minus x squared. That's just 0x squared. So I'm not going to write anything here. I've got 5x, and I'm going to subtract 2x. That's just going to be 3x. All right, so that's the end of this third step. And you can see I'm out of terms. So what I'm going to do is take this 6 up here, and I'm going to bring it straight down. I'm going to draw an arrow, and it's a positive 6. Okay, so I'm going to bring that down and write it next to the 3x. And all of a sudden, you're going to see that I have a new expression here. I've got 3x plus 6. Well, what we're going to do next is we're going to repeat this whole process, starting with 3x plus 6. So we're going to ask ourselves, if we take that 3x, the first term, and divide by the first term in our divisor, what do we get? Well, let's write it out. We have 3x, and we're going to divide by x. Okay, well, I have an x in the numerator and x in the denominator. That's just going to be 3. Okay, so 3x divided by x is 3. Well, where am I going to put that? I'm going to go back up here, and I'm going to put it above the term in my dividend that has no x. Okay, my 3 has no x. Let's put it above the 6, which also has no x. And I'm going to repeat this whole process here, okay? I'm going to take that 3, and I'm going to multiply it by each term in my divisor. So 3 times x, I'm going to say is 3x, okay? I'm going to write that underneath my 3x term here. And I'm going to say 3 times 2, well, that's just 6, okay? So I'm going to write my 6 here. And you might remember the next step is to draw a straight line across, and we're going to do some subtraction. And again, we're going to put that second expression in brackets to keep our signs straight, and we're going to subtract straight down. We're going to say 3x minus 3x is 0, and we have 6 minus 6, that's also 0. So we end up with 0. Now, sometimes when we do division in general, we end up with what's called a remainder. That's what's left over after we do the division, right? Not every number is divisible by every other number cleanly without a remainder. In this case, we actually got a remainder of 0. So what that tells us is that when we take x squared plus 5x plus 6 and we divide by x plus 2, we get x plus 3 without any remainders. Now, the best part about polynomial long division is you can check your answer, right? What I can do is I can say, well, if I divide this dividend by this divisor and I get this quotient, if I multiply these two together, I should get my dividend back again, right? If I take x plus 2 times x plus 3, I should get x squared plus 5x plus 6. And you can check that just by, expanding and simplifying. And I've just done that for you here to speed things up. You're going to see that I do, in fact, get x squared plus 5x plus 6. So we can confirm that when we perform this division, we get x plus 3 as our quotient. All right, so moving on to a more complex example here. You can see I've got a few more terms in my polynomial. I'm working with a degree 3 here. And I'm also working with a binomial as my divisor that has a coefficient in front of the x. I've got 2x plus 1. Okay, so a little bit more complex, but nothing we can't tackle if we use the exact same process as the previous example. All right, so remember, we're going to start with that first term of our dividend, that 2x cubed in this case. And I'm just going to write that off to the side, okay, because we're going to do a little bit of side work here. And we're going to divide that by the first term in our divisor, in this case 2x. Okay, so I'm going to write that divided by 2x, and we're going to see what we get. Okay, whatever we get, we're going to put above our dividend. That's going to be part of our quotient. All right, so I know that 2 divided by 2 is 1, so I'm not going to really need those. And I'm going to just write out the rest of this as a division of powers problem, right? I've got 3 as an exponent, and I'm dividing by a power with 1 as an exponent, so I can subtract those exponents to get x to the power of 2. All right, so that's going to be the first term in my quotient. And since I've got an x squared term, I'm going to find that x squared term in my dividend, and I'm going to put it directly above it. Okay, so the 5x squared here, I'm just going to put x squared. Okay, that's the first term in my quotient. So the next step of that process that we just applied in the previous example is we're going to take that first term and multiply it by the first term in our divisor as well as the second term in our divisor. Okay, so we're going to say, well, what's x squared times 2x? Well, let's just write that out. I'm going to say, what's 2x times x squared? Okay, well, again, this is another exponent laws type problem where I can just add my powers. I'm multiplying powers with the same base, so I can add my exponent. So I'm going to say this is going to be 2 times x to the power of 1 plus 2, right? I got a little exponent of 1 there. Adding those exponents is going to be 2 times x to the power of 3. Okay, so that's going to be what I get when I multiply these guys together. And I'm going to take that, I'm just going to write it directly above the other 2x cubed, okay? And we'll repeat that process by taking x squared times 1. I'm not going to write that out because we know that that's just going to be x squared, right? Anything times 1 is always just going to be itself. So we got a nice little expression here. All right, so that's the end of that step. The next step is I'm going to draw a little line across here, and I'm going to do some subtraction. And remember, when we subtract and we're working with, multiple terms, we like to put brackets around things so that, we don't mix up any of our signs. So subtracting straight down, I'm going to get 0 here. 2x cubed minus 2x cubed is going to be 0. And I've got 5x squared minus 1x squared. So that's just going to be 4x squared. That's the end of that step, but I'm out of terms. So remember in the previous example, we took the next term in our dividend and we brought it straight down so that we can continue dividing. Okay, so we're going to start this whole process over and we're going to look at this expression and say, well, if I take 4x squared and I divide by the first term of my divisor, 2x, what do I get? Again, you can go off to the side and just say, well, if I take 4x squared and I divide by 2x, 4 divided by 2 is 2, okay? And I'm hoping you're getting the hang of this, dividing powers with the same base thing. But x squared divided by x, that's just going to be x, right? So I'm going to end up with 2x. Now that 2x, I'm going to go back up into my quotient, and I'm going to put it directly above the x term in my dividend, okay? So above that negative 4x. You can see that I'm keeping my powers lined up with one another. All right, so the next step is to take that 2x in our quotient and multiply by each term of our divisor. So I have 2x times 2x. All right, well, 2x times 2x, that's just going to be 4, and we have x times x, which is going to be x squared. All right, so as long as you're comfortable with these exponent laws here, things are working out okay for us. So we get 4x squared, and where do we put that? Well, we go back over to our work here, and we say, well, I'm going to put that directly below this 4x squared, and I'm going to do the same thing with that 1. I'm going to take 2x times 1, and 2x times 1 is going to be 2x. So I'm going to write that 2x here, and that's the end of that step. Next step is the subtraction again. So I'm going to subtract straight down. I'm going to put this in brackets, right? 4x squared minus 4x squared. That's just 0x squared. I'm not going to write that. And then I have negative 4x minus 2x. Well, that's going to be negative 6x. And again, I'm out of terms, so I'm going to go back up to my dividend, and I'm going to grab that negative 5, and I'm going to bring it straight down here so that I can continue my polynomial long division, right? You can see I'm missing a term up here. I've got x squared plus 2x, and there might be something at the end there. So we're going to keep going to see if we can figure out what that's going to be, right? So we're going to repeat this whole process We're going to take negative 6x here, right? That's the first term in our expression, and we're going to divide by the first term in our divisor, which is 2x, right? So negative 6x divided by 2x. Well, that's going to be negative 3 because I've got an x in the numerator and the denominator. Those can cancel out, and I've got negative 3. So what do I do with that negative 3? I'm going to stick it right back up here, and that's going to complete my quotient, right? I've now got a complete quotient, but we're not going to stop there because there is a possibility that we could have a remainder. So we're going to take that negative 3 and we're going to multiply by each term in our divisor, and we're going to write the result underneath here. So when I do that, negative 3 times 2x, that's going to be negative 6x, and negative 3 times 1, that's going to be negative 3. Okay, so that's what we're going to get. And of course, we're going to subtract straight down. We're going to slap some brackets there to keep things organized. And when we subtract, negative 6x minus negative 6x is going to be 0. Negative 5 minus negative 3. Be careful with your signs here. This is going to be negative 2. Okay. Now, taking a look at our problem, you can see we've run out of terms in our dividend, right? So we're finished here. Our polynomial long division is complete. We divided that big nasty cubic by this binomial, and we got this quotient up here, but we actually have a remainder of negative 2. And that's okay. That's going to happen. In fact, that's actually going to happen in every one of the following examples. We don't always get clean division. Not everything is divisible by everything. That's just the way the world works. Now, bear with me for a moment here because I've just created this big mess for you to look at. We can check our answer here, but this remainder of negative 2 makes things a little bit more complicated. What I've done is I've just taken my dividend and divided it by my divisor. And I've written it out like this. I've got my quotient with my remainder divided by my divisor. Now, some teachers really like when students write things out like this. So I thought I'd spend just a minute, kind of explaining this to you. But really what this means is, if I take this divisor of 2x plus 1 and I multiply it up to the other side, I would get 2x plus 1 times that quotient. And the divisor would actually cancel out that denominator of 2x plus 1, leaving us with that remainder of negative 2. So this is another way of showing the remainder. I don't usually do this with my students. I usually just tell them, I just want you to indicate the remainder some way. Just writing it at the top of your page, like, hey, I have a remainder of negative 2. That usually suffices for me. But if I'm not your teacher, check with your teacher and make sure you're comfortable with what they're expecting so that, you're making sure your teacher's happy. All right, at first glance, this example looks a little bit simpler than the previous example just because we have less terms in our dividend. But I'm going to spoil the whole thing here and tell you this one's actually a little bit trickier, and I'll show you why. So normally you just start with the first term of the dividend, divide by the first term of the divisor, and you write the result up in the quotient. And let's do that, and you'll very quickly realize that there's a bit of a problem here. So what we're going to do is take that x cubed, and we're going to divide by x, and you're going to get x squared, okay? Well, so what do we usually do with that x squared term? Well, we would normally go to the dividend and we'd track down our x squared term and we'd place it directly above it. But what do you notice here? There is no x squared term. So now what? Well, I'm going to show you how you approach a problem like this. And this is why I did this problem, later on, because it is a little bit tricky to get your head around. But since we don't have an x squared term, we're going to just sort of make a little adjustment to our dividend to include an x squared term. And we can't just randomly add and subtract things without breaking math. So what we're going to do is do this creatively, and we're going to add an x squared term without changing our dividend in any way. And the way we do that is by adding a 0x squared. Okay, that's just a placeholder. It's an x squared term with a coefficient of 0. So we're creatively putting an x squared term into our dividend. Now that we've done that, it makes sense that we take that x squared and place it directly above our placeholder term to start creating our quotient. So this problem from this point forward is going to be business as usual. We're going to take that first term of our quotient and multiply by each term of our divisor, and we're going to place the results, down below. So x squared times x. I'm not going to write that out off to the side. We know that that's x cubed. Okay, x squared times negative 4. That's just going to be negative 4x squared. And of course, we're going to draw a line, and we're going to start doing some subtraction here. And we're going to put everything in brackets to keep our signs straight, right? X cubed minus x cubed is 0. We're not going to write that. We've got 0x squared minus negative 4x squared, also known as positive 4x squared, right? Be careful with your signs there. So we've done our subtraction, and we're out of terms. So we're going to take that negative 2x, that's the next term in our dividend. We're going to bring it down, and we're going to repeat our process, right? We're going to say, well, what's 4x squared divided by x? And I'll write that out for us. 4x squared divided by x. All right, we know that's going to be 4 because 4 over 1 is 4. And x squared divided by x, we subtract the exponents just to give us an x. Now we're going to take that 4x, and we can comfortably place that above our negative 2x because, it exists in our dividend. And that's going to allow us to continue. We can take that 4x and we can multiply it by each term in our divisor, right? We're going to say 4x times x, that's going to be 4x squared. And we're going to take 4x times negative 4 to give us negative 16x, okay? And we're going to take those guys and subtract them. And when we do that, we put the second expression in brackets and subtract straight down, right? We got 4x squared minus 4x squared. That's going to be 0. We got negative 2 minus negative 16 with an x. That's going to give us positive 14x. Again, be careful with your integers there. And we're at a term, so we're going to go back up, grab that 1, which is the last term in our dividend. We're going to bring it down, and we're going to say, all right, we're working with 14x plus 1 now. Well, let's do some division again. 14x, we're going to divide by the first term in our divisor, which is x. I'm not going to write that off to the side because I think it's pretty clear. 14x divided by x, those x's are gone. We're just left with 14. All right, we're going to put our 14 up here above the term in our dividend that doesn't have an x. And that's bothering me, so I'm going to extend that a little bit there. And we're going to do this whole thing one more time. We're going to take that 14 and multiply by each of the terms in our divisor to give us 14x. And we got 14 times negative 4, which is negative 56. And of course, we're going to draw a line. We're going to subtract. And we're going to put this thing in brackets. And we're going to end up here with a remainder of 57. And I'm not going to go over how to write the remainder all fancy here. I'm just going to say I've got a remainder of 57. All right, so when I take that dividend, divide by the divisor of x minus 4, I end up with a quotient of x squared plus 4x plus 14 with a remainder of 57. Not that bad of an example, really, but introducing that 0x squared term, you'll be surprised how many people forget that. And it really gets confusing when you do that first step and, you have nowhere to stick that x squared. And, if that does happen to you, if you do that step and you realize, I have nowhere to put it, let that be a prompt to you to say, oh, that's right, I forgot my placeholder. And, go ahead and put that placeholder and then keep going and things will work out okay. All right, so what's so special about this problem that I saved it for last? You can see right away that I'm not missing any terms. I've got an exponent of 3, 2, 1, and 0 here, so I'm not going to have to add any placeholders. And this problem, it really is a pretty standard issue problem, but there is kind of something weird that happens in the middle of the division process that I want to draw your attention to because I think this confuses a lot of students. And by the way, congratulations if you're still watching this because not very many people enjoy polynomial long division. Fortunately, there is a shortcut, which I will show you in a later video. But for now, let's take a look at this problem. And we're going to approach this the exact same way. We're going to take that first term of our dividend, x cubed, and we're going to divide by x, right? No surprises there. That's going to be x squared. By this point, I think you're probably a little bit comfortable with this division of powers thing. We're going to take that x squared and we're going to place it directly above the x squared in our dividend. Okay, so that's the first term in our quotient. We're going to take that term, multiply it by the first term of our divisor, and write the result right here. Okay, and that's going to be x squared times x, also known as x cubed. All right, so we get x cubed. All right, that was the first term. We're also going to multiply by the second term in our divisor. So x squared times 2, that's going to give us 2x squared, okay? And we're going to slap some brackets around that expression, and we're going to subtract straight down. Now, here's where the weird stuff starts happening, okay? When I do that, you're going to notice we get x cubed minus x cubed, 2x squared minus 2x. That's the same thing. We're going to end up with 0 here, okay? So now what? we destroyed our polynomial long division problem. And to help you get your head around this a little bit, I never really just write 0 when I'm doing polynomial long division. I always keep the variable portion of the term with it. So I don't just have 0, I have 0x squared, okay? I find if you keep the exponents on the variables in order, from the top of your problem straight down to the bottom, things stay organized and things are a lot less confusing. All right, so that's okay. We got 0x squared. Let's just keep going, see what happens. We're going to bring that negative 6x down. That's what we normally do, right? We take negative 6x down and we keep going. Now we're going to say, what happens if I take 0x squared? That's okay. It's just a term, right? If I take 0x squared and I divide by x, right? That's what we do. We take this first term, divide by the first term of our divisor, and we see what we get. Well, 0 divided by anything is 0, okay? But I'm not just going to call it 0. I'm going to call it 0x, right? Because x squared divided by x is x. I'm going to call it 0x. And the reason I do that is because I need to know where I'm putting that term, right? I'm going to put that term directly above that negative 6x, okay? Because it's, it's got the same variable, same power, right? So I'm going to say I'm going to add 0x. I could put minus 0x too. It doesn't matter. It's 0, right? And you can see I'm starting to develop a quotient here. I've got a 0x there, and I've got room for one more term, right? So let's keep going. So I've got 0x, and I'm going to repeat the process just as if that weren't 0, right? I'm going to take that 0x, multiply by x. I'm going to multiply by 2. And when I do that, I get 0x times x, also known as 0x squared. Yeah, it's still 0, but keep the x squared there, right? You can see I've got x squared all the way from the top all the way to the bottom. And I'm going to take 0x times 2. Again, it's going to be 0, but I'm going to call it 0x, all right? Keep your exponent of x consistent as you move down that column in your problem. All right, we're going to subtract by putting that second expression in brackets, right? 0x squared minus 0x squared, that's 0. We have negative 6x minus 0. That's going to be negative 6x. All right, so at this point, we've bypassed all that weird 0 stuff, and hopefully things are a little bit more normal moving forward. And they are. We're going to take that 1, bring it down as our last term in our dividend, and we're going to continue our process. We're going to say, what happens if I take negative 6x and I divide by x? Well, those x's are going to cancel out. I'm going to be left with negative 6, and I'm going to do this all one last time. I'm going to take that negative 6, multiply by my first term in my divisor, multiply by my second term in my divisor, and when I do that, I'm going to get negative 6x, and I'm going to get negative 12. All right. Last subtraction step, I'm going to subtract by putting the second expression in brackets. I get 0, and I get 1 minus negative 12, also known as positive 13, being careful with your subtraction of your integers. So in the end, after all this bizarre 0 stuff, we have a remainder of 13. I'm just going to write that at the top here. And we can say that our quotient is x squared plus 0x minus 6. I would never write, a polynomial with a 0x. I would summarize that as, x squared minus 6, right? Now that you're done with your polynomial long division, it's just don't bother writing that 0x anymore. It's really just helpful to keep that placeholder so that you can keep all your x's in line as you complete your polynomial long division. Hey, thanks for watching this deep dive into polynomial long division. If this video and, polynomial long division in general are too long for you, you're going to want to head over to this video right here where I'm going to introduce you to a shortcut that's going to allow you to never use polynomial long division ever again, and I will see you there.